this video for section 1 of chapter 6. We're going to be talking about inequalities and just properties of inequalities, and then we're going to add in a exterior angle inequality theorem. But you can see all the things that you need to fill in. I don't have to write them in, but you do. So if A is greater than B and C is greater than D, then A plus C is greater than B plus D. Essentially, if I add the two bigger things, that total is going to be bigger than the two smaller things combined. It should intuitively make sense. That's not crazy, right? When I add the two smaller things together, I get a smaller chunk than when I add the two bigger things together. But again, that's not necessarily what it looks like on your paper, right? Because A is going to be a real thing, right? A is going to be an angle. A is going to be a length, right? That when added to C, right, that's also bigger than D, just like A is bigger than B, right? The combined A and C is bigger than B plus D. 2 and 3 are similar things, right? If A is bigger than B and C is bigger than 0, then the product of A and C is greater than the product of B and C, right? Essentially, any number, right? I could just sub in some numbers for this just to make it make sense, because 2 is bigger than 1, right? And if I multiply by any number bigger than 0, so if I multiply by 2, right? 4 is bigger than 2. That makes sense, right? 2 times 2 is 4. 2 times 1 is 2. 4 is bigger than 2, just like 2 is bigger than 1. And the division part of it works as well. 2 divided by 2 is 1, and 1 is bigger than 1 divided by 2, 1/2. So whether I'm multiplying or dividing, as long as it's the same factor, right? If A is bigger than B, then A divided by C is bigger than B divided by C. 3 is only different because C is going to be less than 0, which means it's actually going to be negative, right? So again, 2 is bigger than 1, like we talked about before. But if I divide by -1 or multiply by -1, -2 is actually smaller than -1. So again, this isn't going to happen very often for us, right? We don't have a lot of negative things that we deal with in geometry, but definitely could happen. 4, A is greater than B, and B is greater than C, then A is greater than C. That's what we just called transitive, right? The transitive property in the past. And it still is. We're going to use that. But we no longer get to say substitution in this kind of situation because there are no equal signs. So that's what that other video was for that you watched. Only transitive in these situations. And then 5, A is equal to B plus C. So if A equals B plus C and C is greater than 0, then A is bigger than B. A is also bigger than C, right? That's the total is always bigger than the two parts. It has to be, right? The only way this wouldn't work is if it was like a construction example, right? Because sometimes we added a couple lines together and we got a longer line, right? But then we would work our way backwards with our compass. We subtracted length B, and then we just have this length here. So the final product, if I'm adding and subtracting, could actually end up smaller than any of the pieces. But most of the time, right, A is going to be bigger than the two parts that you add together. Because again, we don't have negative angles and we don't have negative lengths that we worry about very often. So all of those are properties of inequalities. And in proofs, we're just going to put that in as, right, an abbreviation here, property of inequality, right? So if you want to shorten it up, that's what we would write. But otherwise, we have one theorem down at the bottom that obviously you can pause and write that in. You need that. But it's just saying if I draw a figure here. If you guys remember, this exterior angle measure here is equal to the sum of the two remote interior angles. So if I added those two red angles together, I'd get that blue, right? And because of that last property of inequalities, A, being the exterior angle, right, is equal to B plus C, right, the two remote interior angles. So A has to be bigger than B and C, right? That blue angle is definitely bigger than either of the red angles. That's what this theorem is for. I can shorten this one again. In a proof, we're just going to say the exterior angle inequality, THM, would be theorem. So you're going to need this. You're going to say that sometimes. Sometimes you're just going to say transitive because it's a series of inequalities. And then other times you're going to need this properties of inequalities, that shorthand, because any of the situations 1 through 5, they're all properties of inequalities. But sometimes we have to be more specific, like transitive, or maybe we'll use that exterior angle inequality theorem. So finally, the examples over here. Two different things that we'll do on our worksheet. The first one, for all of these, given this triangle situation over here, I'm supposed to say, do I know enough to say that 1 is equal to 2? Again, 1 could be equal to 2. It visually doesn't seem like it would be, but if I told you that DB bisected angle ADC, then 1 would have to equal 2, right? But I didn't say that. I didn't give you that information. So right now you're just supposed to say, no, I don't know that 1 is equal to 2. You can only say yes if that absolutely would be true. So on the second one, on B, 1 plus 2 is definitely equal to ADC, because that's just angle addition, right? We don't need a reason right now, but later in a proof, you just call that angle addition because that's what it is, right? Otherwise, A plus 1 is equal to the measure of angle 3. That's what we just talked about in that last proof, or in that last theorem, excuse me, right? This exterior angle 3 is equal to 1 plus A, so that is definitely going to be true. But is 3 bigger than 1? Yes, because of that last theorem, right? We were just talking about those things. Now, the theorem, the exterior angle inequality theorem, is actually what goes with that D example. C is just the old theorem where the exterior angle equals the sum of the two remote interior angles. So this is just an angle addition / old theorem that we had, but D, that's our new thing, right? And then we go to E there. Can't get this thing to work. And 3 is bigger than 2, that's what it's saying. Now visually it does look like 3 is bigger than 2, but there's nothing in my figure that actually tells me that it has to be bigger than 2. So again, I'm going to say no here, but that doesn't mean that it's not bigger than 2. It just means that I can't prove it yet. I don't have enough information to prove it. And then F is A bigger than ADC. Well, again, I don't really know. It could be, but that doesn't mean it has to be. So if you know a reason, you're going to say yes. If you don't know a reason, you're going to say no. So again, it's not always saying that that's definitely true. Like A, 1 might be bigger than 2, but I just don't know enough information yet to prove it. Because your proofs look like the one down below. We just have to fill in the blanks, fill in the reasons on the side. You do need to change your notes. You don't have an equal sign here, so make sure yours is an equal sign, because that was just a mistake when the notes were made and something that hasn't been caught. So make sure you fix that. There's an equal sign there. But otherwise, number one is always just a given, right? So I know what goes there. So if CO is perpendicular to OB, I'm supposed to prove that DOB is smaller than angle COA. This first equality, though, BOC and COA, those are just the two angles formed by my perpendicular lines. And I do have a theorem from a long time ago. That might be hard to remember, so use that cheat sheet I gave you if you're looking for stuff. Perpendicular, if and only if it forms two congruent adjacent angles. Right, so that was the theorem from like chapter 2 or something a long time ago. You should still know that. You can still use that. The rest of these things, though, should be a little bit more apparent. Maybe be a little easier. COD plus DOB equals BOC. That's just saying that this angle 1 and this angle 2 add up to the big right angle. So that's definitely true because that's just an angle addition. Whereas when I say DOB is smaller than COB, when I say this is smaller than this, that's just a property of inequality, one of our new things, right? A part has to be smaller than the whole, right? If I add COD and DOB together to make BOC, then DOB has to be smaller than COB. Then finally, I'm trying to figure out, okay, DOB is smaller than COA. The only thing that changed from 4 to 5 is instead of having a COB, I have a COA. And that's because I know those things are equal up here, right? And that's when I'm going to say substitution, right? Now this is what confuses people. Again, if all I have are inequalities, then it would be a transitive. But this is a substitution because of that equal sign that I made you change a second ago. If you mix and match, if you do have an equal sign somewhere, it's definitely going to be a substitution. Otherwise, sometimes it's just a transitive. So you have to learn to differentiate those things now. Otherwise, that should be good enough for this video.